Woo! Yeah, baby. Let's get it. Let's get it. Let's get it. I'm wearing my famous disco ball jacket because we are on video number 10, ladies and gentlemen. You should be feeling good. If you have been on topic, making sure you're focused on these videos, that means you've reviewed 10 important topics for our IA number 2, and you are so much closer to getting those 25 out of 25 corrections correct and dominating next week. This is our last video. It should be a Friday if you are on track. Let's check out video numero 10. Alright, number 10, graphing unit rates. We've talked a ton about unit rates. Unit rates are something always per 1. We can take that pattern per 1 and then continue a pattern. So for example, let's say that I can throw a ball in the air 5 times every 1 minute. Well, if I have 2 minutes, then it's going to be 10 times. 3 minutes, 15 times. All that's happening is I'm taking that unit rate and continuing it. You're going to do that a ton when you get to 8th grade and 9th grade on graphs. So this lesson might seem easy, but this is actually something that's really supporting you guys as you get into higher level math, especially with slope and algebra. So let's check this one out. It says a car traveled 140 miles in 4 hours at a constant speed. When I see constant speed, that means that we're going to be having the same speed every hour. So if we're going like this, we're having the same speed walking every single hour. It's not going to be like slow. It's going to be the same speed. So constant means same. How many miles did the car travel per hour? When I hear that word per, I'm not thinking of Catman. I'm not thinking of this cat being like perfect. You are thinking of something per or to 1. So I want to know how many it could go in 1 hour or per hour. Let's check this out. First things first, I want to find my unit rate. We know we always use division. We take our total and divide it by the time, or we divide it by how many items we have to figure out our unit rate. So I know that this car is going to go 140 miles, and it covers this distance in 4 hours. When I divide this, I'm saying, okay, if this is the total distance in 4 hours, let's break it up and get it in just 1 hour. So I'm going to say how many 4s are in 100. That's going to be 0 because 100 is smaller than 4. Now I'm going to look at 14. How many 4s are in 14? That's going to be 3. 3 times 4 is 12. I subtract and I get 2. Bring down the 0 and I'm going to get 20. How many 4s are in 20? That's going to be 5. So when I write this unit rate, I just don't want to say 35. I want to make sure I understand the context or the situation it's in. And that's going to be 35 is how many miles this car would travel in 1 hour. That should make sense because 35 times 4 would be 140. And that's what we just said for 4 hours. And we also know this is a constant speed, meaning it's going at the same rate continuously. So we're going to take this 35 miles and we're going to put it on our beautiful number line over here, okay? Our x value is the thing that goes on our horizontal line. It's the thing that's going to be in our denominator, okay? The distance we travel depends on how long we're traveling for. So time is something that's always, or at least almost always, on the x-axis. This is something called the independent variable, which you should know about from your science teachers. So our time is down here, and then if the time is here, our miles or our distance is going to be over here. So I'm going to write distance this way. So this little graph is going to show us that constant speed. Okay? All right. So over here, I'm going to fill in my time for my x value and my distance for my y value. For for hour number 1, that's going to be 35 miles. And also to this word distance, you probably should add the letter m. That's just telling you that the distance is measured in miles. If I were to go 2 hours, meaning like I'm now driving for 2 hours, the amount I drive the amount of time that I drive for is going to actually impact how far I can drive, right? Just if I told you, you guys have this big test, but I'm going to give you 1 minute, you wouldn't do that well. But if I gave you the same test and gave you an hour, you would have more time. So your performance on the test depends, which is why it's the dependent variable or the y variable, depends on the time you have to work on it. So if I have 2 hours, that's going to be 2 groups of 35. So I can add 35 and 35, and that's going to be 70. If I have 3 hours, that's just going to be another group of 35, and I can add 5 and 0 is 5, 3 and 7 is 10, so that's going to be 105. If I have 4 hours, I'm going to add 35 plus 105, and I already should know I'm getting this right because it's 140. We have that up here. Okay, so again, our x value is our time, and our y value is going to be our distance because that depends on that. Okay, now we actually want to graph this, and this graph is kind of cool because it's going to show us that constant rate. You're going to see that it's going up at the same time. Okay, so I'm going to count over here. We know that this spot right here is the origin, or 0, 0. So I'm going to put this as a 1, 1, 2, 3, 1, 1, 2, 3, 2. I'm just doing this so it's kind of spaced out so I can see it really clearly. And what's cool is this graph is going to go on forever and ever. It's going to be a line that just keeps continuing. I'm just doing this so my x values are going to be nice and spaced out. Now, up here is where it's a little bit trickier. I actually want to go from here to here and get at least to 140. So I can't count by ones, because if I do that, I'm going to just get 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So there's 20 here. But if I count by ones, I'm never going to get to my first hour of time being 35 miles. So instead, I think I'm going to count by tens. So this line right here is going to be 10. This one will be 20. This one will be 30. You get the idea. It's really hard for me to write that so small. So I'm going to try to make my pen a little bit, and then make this one 40. I'm going to put a 5 for that's 50, 60, 70, 80, 90, 100, 110, 120, 130, 140. Okay. Kipsters, I apologize, but it's really, really hard to write with my little mouse. This is how I'm writing, so you guys have a pencil, so I know yours can look way better than mine. But right now I want you guys to label our lines going up on our y-axis as 10, 20, 30, 40, all the way up. The top line should be 200. Go ahead. Okay, hopefully you are there. You have each of those being counting by tens. Now, for our first hour, I also should write that our time is in H for hours. Our first hour is going to be 35. So I'm going to count 10, 20, 30. 35 would be right in the middle about there. Okay. Now I'm going to go to 2 over here. That's going to be 70. So I can count 10, 20, 30, 40, 50, 60, 70. That's going to be right there. When I go to my third hour, that's going to be 105. So I'm going to go 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110. So that's going to be between. And then if I go to 4, that's going to be 140. So 10, 20, 30, 40, going all the way up. That's going to be right about here. And I literally could just keep taking this line. And what's kind of cool, even from those little red marks, you should see that it's this perfectly straight line, and it's increasing at the same amount every single hour. Hashtag constant. What that means is like it's the same. It's not increasing like this and then like this. It's going up at the same rate, which is why it's a unit rate, and it's got a constant speed. So I'm actually going to show you how cool this is. If I actually take a line, and this is the one thing my computer can do cooler than what you guys can, if I start at 0, 0, because at 0 hours I would go no distance, I can literally draw this perfectly straight line through all of my points and continue to go up, up, and up. Okay, that's going to give me a perfectly straight constant speed. So I can kind of see, I could keep going up and kind of predict where 5 would be at, or I can just multiply because I know every hour we're going to be going 35 miles an hour. This last question is, how far can we travel in 9 hours? Well, if I know that number is 35, because it's my unit rate of 35 miles in an hour, I can do 9 times 35. So over here, I'm going to do 35, which is, 35, which is my unit rate. 35, which is my unit rate. And I'm going to times it by 9, which means I'm going to be going 9 hours. So I'm going to be driving. I can keep going and going and going and going and going on my list. I would get 5, regroup the 4 tens. 9 times 3 is 27 plus 4, 28, 29, 30, 31. That would be 315. So how far we could travel in 9 hours? We could travel 315 miles. Okay, so like I said, this is taking our unit rate and actually graphing it. It's really cool because we can see this perfectly straight, constant line going with our speed over time. This is something that's going to help you a ton. Some really cool just math curiosity and trivia for you. This right here is actually something called y equals 35x. That's not something you'll have to know until you're at least in 7th grade, but that 35 is actually what we call the slope. So if you want to bust out some cool knowledge later with your friends, be like, oh, the constant speed on a graph is just the slope. Yo. So, congratulations again for finishing all your videos. You guys should feel golden and fantastic. Thank you all for working hard and making sure you get this done before the start of our IA number 2 next week. Kill it. Love you guys.